Hey my friends, Shawn here from theautomationblog.com, and in this episode of the Automation Podcast, I sit down with Thomas Haneder from Siemens in Germany to get a real technical presentation on PROFINET. That's Siemens Industrial Ethernet Network. And if you're somebody who really likes details and likes bits and bytes, I think you'll really enjoy this week's episode.
Thomas, thank you for putting together this presentation for us. I'm looking forward to learning all about PROFINET. So could you start by introducing yourself to our audience and tell them what your role is?
Yeah, sure. Thanks, Shawn, for letting me part of your podcast. My name is Thomas Haneder. I'm Technology Manager for Industrial Communication. I want to talk about PROFINET in general and what are the difference between PROFINET and standard Ethernet communication, as well as how does PROFINET real-time and PROFINET isochronous real-time work and how does it fit into the OSI model. Okay, so let's talk about PROFINET in the automation environment. Considering the automation pyramid with its different layers, PROFINET with its scalability in terms of performance and quantity structure, it is used in field level communication to connect decentral I/O, industrial identification, and high performance motion control applications. But also on controller level where machines or PLC communicate amongst each other or with any kind of HMIs, you will find PROFINET at that level. Controller northbound communication where performance requirements are not as critical, it is commonly realized with protocols like OPC-UA or TCP/IP and any kind of derivatives. With PROFINET, these protocols can run on the same network, so on the same infrastructure, and without interfering the transmission of real-time critical process data, where we need here on field level. So PROFINET in an automation environment is fully compliant to IEEE 802. It supports 100 megabit full duplex with auto crossover and auto negotiation. It supports communication on various media types such as copper, fiber optic, and wireless communication. And due to bandwidth reservation in case of PROFINET IRT, PROFINET supports the transmission of non-critical data such as standard TCP/IP protocols or OPC-UA, or recently more often in combination of IIoT, mentioned MQTT protocol, all on the same network. Built-in mechanisms take care that time-critical data always arrives on time. So PROFINET is suitable for all kinds of performance requirements. So talking about process automation where we have like 100 milliseconds or above, and for factory automation or motion control application where we have 31 or 25 microseconds with a jitter less than 1 microsecond. A broad range of proxy devices are available as well for migration purposes in terms of want to add like Profi bus field buses. You want to connect those to PROFINET and any other CAN field buses, whatever what you have on the network. So PROFINET provides native support for safety-related applications. A separate connection is not necessary to realize a functional safety application. And it supports up to SIL 3 level. It is guaranteed. Various profiles like Profi Drive and Profi Energy are available as well in order to support an easy integration for various purposes. So what is the difference between standard Ethernet and real-time Ethernet, such as PROFINET? So for standard Ethernet, which is based on the best effort principles, we have quality of service which is quite situation dependent. In terms of when we have like a low network load, we have a low latency and we have constant throughput. So that's okay. But if we have a high network load, we have a high and volatile latency and a volatile throughput. And all of that is not suitable for industrial control systems. So with PROFINET, which is based on a TDMA principle, time division multiple access. We have a quality of service which is independent of the network load. Both in empty or congested networks, we have a low defined latency and we have a constant defined throughput. So that quality of service is required for industrial control systems. So PROFINET defines its functionality within conformance classes, where we have like in conformance class A, in conformance class A, devices support real-time real-time cyclic data exchange as well as parameterization and alarms. It supports topology information, and conformance class A devices are commonly used in infrastructure and building automation. So each conformance class on the right side adds functionality to the conformance class we had on the left side. So conformance class B devices supports all functions which are supported by conformance class A devices. In addition, it supports network diagnosis via SNMP, so simple network management protocol, and it supports system redundancy functions, or you have like mostly in process automation. And conformance class B devices are commonly found in factory automation and process automation. So conformance class C devices need hardware support for the bandwidth reservation. We will come to that later on. And it also needs synchronization of the network nodes. So each network has to be synchronized with a sync master so that they have a common understanding of the time on the network. And those conformance class C devices are commonly used in motion control applications where precision is key. So a newly defined conformance class, which is called conformance class D, it is mentioned with version 2.4 of the PROFINET standard, and it's actually in addition for PROFINET at TSN. And those conformance class D devices, they have a network management engine integrated. So those applications on the left side, conformance class A and conformance class B devices, are not synchronized with the application, whereas conformance class C and conformance class D applications are synchronized with the applications. And those features can be extended with optional additional functions where we're talking about like fast startup, like media redundancy, like multiple access. The term here is shared device, and some other optional additional functions. So now we talked about the PROFINET features. So each PROFINET device shall support a minimum feature set. The basic feature set PROFINET's device has to support is the Cyclic Data Exchange. Now that's the Cyclic Data Exchange between a device and a controller, and as well as record read and write services. That's our Acyclic services, and diagnostic and maintenance. So that's a big thing in PROFINET. PROFINET devices offer a broad range of diagnostic and maintenance functions. And as well as I&M data, where we have like the extended device identification information, like where is the device located in the plant, when was the installation date, any kind of comments or signatures. Signature from the installer. Besides the basic functions, PROFINET supports optional functions. Those functions, they don't have to be supported by a device vendor, but a device vendor can easily integrate them. They are predefined in the standard, and usually all PROFINET stack providers provide those functions. They have to be enabled by the device vendor, and they can be supported then. So talking about the optional function, there's a shared, for example, there's shared device. That means like a device can share its IOs to more than one controller. Or also system redundancy. This function is for high availability systems, and it supports various characteristics from device redundancy to controller redundancy. And also like media redundancy protocol or media redundancy. But later on, when we come to the topology section, we will talk more about that.
Nice.
Okay, so primarily today in this podcast, we are talking about the basic functions: cyclic data exchange, record read and write, and diagnostic and maintenance. So some basic terms in with PROFINET is the device class, and which device classes are supported by PROFINET. So first of all, we have the PROFINET IO supervisor. The role of an IO supervisor is commonly covered by an engineering system, which is used to parameterize the network, or writing the user program, or collecting the diagnosis from other network nodes. For example, for Siemens it's TIA portal, but there's also like others from different vendors. Another device class is the PROFINET IO controller. So the PROFINET IO controller is typically integrated in a PLC or in a motion controller. It hosts the configuration data of all devices which are dedicated to the IO controller. It initiates the communication towards the IO devices on the network. And it exchanges cyclic process data with all the devices and is controlling the process. Another device class is the PROFINET IO device. A PROFINET IO device is commonly integrated in a sensor or actor, like a drive or any IO block or a valve. It provides the cyclic input data from the process and to the PLC, and consumes cyclic output data from the PLC. The IO device hosts process or network diagnostic data and issues alarms in various situations where we have like process alarms or diagnostic alarms from the network interface, and it has a passive role in the network. So those devices are connected via Ethernet or Ethernet physics. And the IO controller provides the configuration data to the IO device and consumes the process data from the IO device. Whereas the PROFINET IO device also issues alarm data from the process. The PROFINET IO supervisor reads diagnostic data from the IO device or also status and control data, and can also provide parameterization data to the IO device. Now we had the term application relations, so we have those two roles. It's one role is the IO controller, the other one is the IO device, and between them we have an application relation. As mentioned before, the IO device has a passive part on the network. The IO controller initiates the data exchange to the IO device. This is called the AR Connect, Application Relation Connect. In this phase, the IO controller writes the parameterization to the IO device. And after that, the device is in data exchange with the I/O controller, and the data exchange is follows by the provider-consumer model. So within an application relation, we have various communication relation. So one communication relation is the record data communication relation. The record data communication relation is used by the I/O controller to read and write data records for parameterization or read diagnostic data from the device. The record data communication relation is an acyclic service and it uses the best effort communication channel. So talking about communication channels, we're gonna pick that up later on. But for now, you should know it uses the best effort communication channel. Besides the record data communication relation, we also have the I/O data communication relation. The I/O data communication relation is a cyclic communication between the I/O controller and the I/O device. And within the I/O data communication relation, process data is transferred between I/O controller and I/O device. The cycle time of that I/O data communication relation has to be defined prior in the network configuration.
Okay.
So another communication relation is the alarm data communication relation. It is used by the I/O device to signal an alarm towards the I/O controller, like process alarm, like a diagnostic alarm. Process alarm could be like an over temperature. Diagnostic alarm could be like a line break or something. And PROFINET defines various alarm types. As mentioned before, one of them is process alarm or a diagnostic alarm. And the alarm communication relation is acyclic, and it uses also the best effort channel. So this is the term application relation. Now I have another slide for application relation where the I/O controller, while physically connected to the I/O device, maintains the application relation to multiple I/O devices. Towards one I/O device, it maintains an application relation. There could be some exceptions, like there's a feature, it's called CURE, or which is called like configuration in run. Here the I/O controller has temporarily a second application relation. The modules of an I/O device can be shared to multiple I/O controllers. If you can see here, like this I/O device here shares its I/Os to more than one I/O controller. A typical use case is like one controller uses standard I/Os, whereas the other I/O controller uses fail-safe I/Os. That's a typical use case for that. And then we have like the feature is called shared input. When you have like input data on a device, so this input data can also be shared amongst more than one controller. Output data, with output data it's not possible because that makes no sense. The next term is device model. So you can see here like a I/O device physically, like here we can see like a decentral I/O block where the device model of PROFINET defines the term slot and subslot. A slot is a place where an I/O module can be inserted in case of a modular device, and it can host one or more subslots. So you can see the slot here, and it can host one or more subslots. So the subslot holds the actual I/O data. The granularity of the I/O data, bit, byte, word, whatever, is determined by the device vendor. And a subslot can be divided into channels, whereas channel is actually represents a single input or output signal. So you can see here the GSDML file. This GSDML file is actually the device description file where technical features and expansion possibilities with modules are described by the device model, and the device vendor usually provides those information of its devices or device family in the device description file, which is called a GSDML file.
What does GSDML stand for? It's like XML?
It's in an XML format. GSD is General Station Description Modeling Language. So that's actually you also have that if you have like a Ethernet IP device, then you also have like also a description file. Same here. You use that description file, you import it into your engineering system, and then you can like configure your device. So that is actually what you use that file for. Okay. So a device can actually be modeled as a compact or modular field device. In case of a compact field device, the structure of slot and subslot is fixed. And with a modular field device, it's variable. So you can actually add like slots at the end of your device model, and you can extend it with various slots or different submodules. Whereas in a compact device, it's a fixed layout. A special module is the device access point module. It is the addressable module of the device itself. So this device model actually with slots and subslots is used to address I/O data as well as record or acyclic record data. So for that purpose, the device access point is a special module where you can address the device itself.
Will that always be where you bring in the PROFINET cable? Is that the device
Yeah,
we're talking about?
we're talking about the device access point is a specific subslot. It's the subslot 0, but then we have also like the interface submodule, which is actually also a special submodule, and we have the port submodules. And like the talking about an interface, here you bring in all the network parameters like device name, IP address, and all that stuff. And for your question, the device access point submodule is not the interface submodule, but it's always usually it's modeled like that. At on slot 0 you have the device access point plus you have the interface submodule and the port submodules.
So if I had a remote rack of I/O and the first module was the PROFINET module, and then I had a bunch of I/O modules on it, each of those I/O modules wouldn't have wouldn't be considered a DAP or device access point.
That's
only
right.
Only the one that connects it to the Ethernet.
Yes.
To the PROFINET. Okay, good.
Yeah. Okay, so by addressing a submodule, data records can be read or written. And the type of data record is addressed by using a specific index. Data records, there are predefined data records in the standard, like the diagnostic data of a device, or the device identification data. Those are predefined records, but a device vendor can also define its own records. So there is an address space for the device vendor where he can provide its own data records. And also for accessing I/O data, this addressing scheme is also used. Like if you want to address data from a specific subslot, then you need to know where's the subslot located, on which slot, and then you can access the data. So PROFINET, we have very flexible topologies within PROFINET. We can have a simple line structure where you have to say like each PROFINET device typically has like an integrated two-port switch that allows like a line structure. And besides the line structure, we also have like star topologies where by the usage of a switching device. And from star, we also have like tree topologies. You can see here like the yellow color is like it's ProfiSafe. That's the integrated safety what we have with PROFINET.
Okay, yep.
And besides the line and tree topology, we also have like a redundant ring topology that is like media redundancy. And it has like we have like MRP, which stands for Media Redundancy Protocol. But besides these media redundancy protocols where we have like switching times of 300 milliseconds, we also have a bumpless media redundancy, which is called like MRPD, which is media redundancy planned duplication, where the frames or the data is sent in two directions, and in case if you have a wire break or a cable break on the network, you won't lose data, and it's bumpless.
Nice.
And besides that, PROFINET also supports wireless communication. Also with ProfiSafe. Functional safety also works wireless. Yeah, so what is that? What that means? You have less cabling. You have an easy commissioning. Line topology and redundant ring structures are possible with additional network components. We had that, and what we also have, you can have several controllers on one network. So let's say you have one network, you have two controllers, you have various I/O devices, and a part of the I/O devices are connected to one controller, part of the I/O devices are connected to other controllers.
Now I have a question, and I don't know if I'm reading too much into this,
Yeah.
but the only way I don't see the dashed line where it's both ProfiSafe and PROFINET
Yep.
is in the star configuration. Is that just am I reading too much into that? Can you do ProfiSafe in a star configuration or no?
In a star configuration, yeah, you can do ProfiSafe, of course.
Okay.
Yeah. Good. So then we're gonna go to the bits and bytes of PROFINET. We have the PROFINET Frame, where it is embedded into a standard Ethernet frame. And here you have the ETHER type, where you have like PROFINET with 8892, or you have standard IP communication with 800, or IPv6, and so on. So with PROFINET we have the 8892, and the PROFINET frame is actually structured. We have the frame ID, and then we have the I/O data. And the I/O data is actually it's structured into I/O data objects. So we talked before about the submodules. So each submodule has an I/O data object within the Ethernet frame. It also has a provider status, and it also has a consumer status. A provider status you can see as a qualifier. So let's say on the I/O device you have somebody pulled the module. So the data is still be transferred, but the data is not valid. That means the I/O provider state goes from good to bad, and the I/O controller can check that value, and it sees that data is not valid.
Excellent.
So that is for diagnostics. So but besides that, the I/O device will also send send an alarm for that. But alarm is acyclic, so the controller has to get in action really quickly. So it can say it can check it by checking the provider state. So talking about the PROFINET real-time and non-real-time frames, which are coming into the network interface. So we have like with an EtherType 800, that's a standard IP protocol or a standard IP frame, and this frame goes through all layers through the network until it comes to the application. So that takes time, and it's not quite reliable. So therefore we have the EtherType 8892. So this EtherType, it goes directly to the application. So it doesn't have to go through all the network layers. It goes directly to the application. So therefore we have like the benefit of for the communication. Okay. So we were talking a lot about cyclic data exchange. So with PROFINET, PROFINET is very scalable in terms of performance for all kind of applications. So you can see on the right side we have like for motion control applications, PROFINET is specified to go down to 31.25 microseconds for motion control applications. And it can go up to 512 milliseconds for process application. If you have like a temperature or you're controlling a temperature, then you don't need to update your data in 31 or 25 microseconds. It's 512 milliseconds is quite enough. And all is on one network. So PROFINET distinguishes between PROFINET RT, which is like real time, it stands for real time, and PROFINET IRT, which stands for isochronous real time. So PROFINET real-time communication is cycle times 1 millisecond and above, and isochronous real-time communication is below 1 millisecond. And for isochronous real-time communication, we have like a jitter below 1 microsecond. So those applications are motion control, high performance motion control applications. So with PROFINET real-time can be realized with any standard Ethernet controller. If you want to create your own device and you want to support PROFINET real-time, you can do it with a standard Ethernet controller. But with PROFINET IRT, you need a specific hardware, you need a specific ASIC to create your PROFINET device. That is because of we need like synchronization. So each node has to be synchronized within the network, and here we need hardware support for that. And as I said before, synchronization is accomplished by hardware, and specific ASICs are needed for PROFINET IRT. And with PROFINET IRT, the communication cycle is split up into an IRT channel, isochronous real-time channel, and a standard channel. So before I talked about best effort channels, or like data records are transferred within a best effort channel, or alarms are transferred within a best effort channel. That is actually the green part here. So IRT data is always transferred in the red channel. So that's actually important, and so with that data, within the IRT time period, we only transfer IRT data, and the rest of the cycle is open for standard communication, like any kind of web server, like OPC UA, like any kind of HMI communication, whatever. the green part of the cycle is open for any other communication. And as I said before, for PROFINET RT, any standard switches can be used. You can go to Best Buy and buy a standard switch. You can use that for PROFINET RT communication, but for PROFINET IRT, managed PROFINET IRT switches has to be used.
Okay.
So coming from cyclic data, now we go into acyclic data exchange, where this is used for data record read and write. So the data record read CR is used for data record read and write, and it's based on the UDP protocol. Data records are addressed by an index and by the geographical address. Geographical address is like the slot, subslot of a device. Okay. And data records are also used for parameter assignment during the startup of the application relation. And and the configuration for the device is written during the AR Connect, and it's also used for reading diagnostic data from the I/O device. And besides the predefined data records, which are defined in the PROFINET standard, there are also each manufacturer has the possibility to specify its own data records. Those data records are usually written in a GSDML file as well. And the system-defined data records, which are defined by the PROFINET standard, they providing information about network and device diagnosis, like the diagnosis data of a device, where you can read the diagnosis data which are stored in the I/O devices in I/O devices diagnosis database. And each device also has to support or shall support the identification and maintenance data for identification of an I/O device, where the vendor ID and the device ID are stored. Now here on the right you see some examples for data records, like the IM0 data record, which has the index AFF0. And this data record provides information about the hardware and firmware of a device, like the vendor ID, the order ID, a serial number, hardware revision, software revision. So this stuff is provided by IM0 data, and each PROFINET I/O device has to support this data record. So if you have a certified PROFINET I/O device, you can read out this data record. Those data records are usually used for asset management. There is also an asset management record where you can store additional information for the like a machine or a robot. Now we are talking about the device diagnostics. Each PROFINET I/O device provides a broad range of diagnostic information. It is split up into network-related diagnostics and application layer diagnostics. So the network-related diagnostics are uses standard IT protocols like SNMP, which stands for a Simple Network Management Protocol, or LLDP for Link Layer Discovery Protocol, or HTTP, to provide information about link status, bandwidth utilization, some statistic information. And these diagnostic information are stored in the standard MIB, Management Information Base, and can be read by any kind of SNMP tool. You don't need a specific tool. Just take any SNMP tool which you can download from the internet, and you can read out those informations.
Nice.
Yeah, and then we have the application layer diagnostics. So the application layer diagnostics provides PROFINET specific diagnosis. Besides the diagnostic information itself, the diagnostic source, as well as the severity of the fault is provided. A severity can be like normal, it can be or normal operation, it could be a fault, it could be maintenance demanded or maintenance required. So not every diagnosis has to be a fault. It can be also like maintenance issues or whatever. And PROFINET defines various error types, but the device vendor can define its own error types as well. So besides the system-defined error types, which are already defined in the standard, each PROFINET vendor or each vendor of a PROFINET device can provide its own specific error types. And in order to signal an event to the I/O controller, PROFINET uses alarms, or each I/O device uses alarms to signal a status change. Like you have an incoming event, you have an outgoing event. This is signaled by an alarm. And we talked about before, we have a diagnostic alarm. This diagnostic alarm signals like stuff like where you have like a wire break, something related to the network itself. And then we have like process alarms. This stuff is related to the process itself. Like we have like over voltage or over temperature. The device vendor can also enrich the diagnostics information with some extended diagnosis. So that could be like in terms of an over voltage or over temperature. It could be like the temperature itself, so the value itself. That is the extended diagnosis of a device. And each diagnosis is stored in the diagnosis database of the I/O device and can be read by any PROFINET tool. It can be read by the I/O controller, but it can also be read by the I/O supervisor.
Okay.
Okay, so Shawn, I mentioned before that I want to talk about the configuration of a PROFINET I/O system. So now this is the slide. So we have the I/O.
Excellent.
Yeah, we have the I/O controller and we have the engineering system. So, and we have the I/O device, and each I/O device comes with a GSDML file, the description file, which defines the functionality and the device model. And those are connected via Ethernet, and the first step is to import the GSDML file to the engineering system.
Now, is that built into the device, or is that something that would come separate from the actual device?
It's a file. It's structured as XML file, and it comes separate. Usually, the device vendor, if you're gonna order your device, you're gonna get your package. There is the device, and the GSDML file you can download from their website.
Okay.
So that's actually where most of the vendors handle that. And then you want to set up the PROFINET network, you take the GSDML file, you import it into your engineering system, like TIA portal, and then you have that device in the hardware catalog. So after you import it, you have to configure your device, like you have to set an IP address. You have to, or you don't have to set the IP address because PROFINET is name-based, but you can set the IP address. You also set a device name, and all that related stuff you have to configure within the engineering system. After that, you set the device name on the device itself with the engineering system or any other kind of tool. And after that, you download the hardware configuration to the I/O controller. And what happens next is the I/O controller will scan the network for that specific device within the configuration. So it will send out a DCP identify request. Like DCP is the Discovery and Configuration Protocol of PROFINET. And after it found the device, it will initiate the AR connect, the application relation connect. And then it writes the configuration to the IO device, and then the IO device is in data exchange.
Excellent.
So now we talked about the configuration of the network, and now I want to share some information about the profiles. So when we're talking about profiles, profiles are actually applications which are on top of PROFINET, which using the PROFINET stack as a communication medium, and those profiles are, they usually have a functional device structure and architecture. They have a specific data structuring of process input output data. And they also have like profile specific identification and maintenance information. So one of those profiles is the Profi Drive profile. So actually Profi Drive profile is used for like motion control drives, and it sits on top of PROFINET. You can say you have a Profi Drive part on your drive, and you have a Profi Drive part on your IO controller. And that's actually, it has a generic interoperable application interface where you can it makes it transparent to configure any kind of device which supports Profi Drive. So if you have like a Profi Drive IO device or Profi Drive supported IO device from a vendor A and one from vendor B, then it doesn't matter. The IO controller won't see any difference. Yeah, and then there is another profile which is Profi Safe. That's actually for functional safety, and PROFINET is used as a black channel here. And another profile would be Profi Energy. Profi Energy is for saving energy. There's some specific commands where you can put your machine into like in a break when you do like a lunch break, or you stop, you have a stop or whatever. Then you can use the Profi Energy profile. Then we are through.
So I really appreciate it, Tom, for taking the time out of your busy day to go through this with me and with the audience.
Thank you. I appreciate as well to be part of your podcast.
Well, I hope you enjoyed that. If you're really into bits and bytes and knowing how things work, I think you will. I know I did. And I really want to take a moment to thank Thomas Haneder from Siemens in Germany for taking time out of his busy week. He has a very large area. I think he pretty much covers the world. And, to give us this technical presentation, which I thought was just awesome. Now, if you'd like to help the Automation Podcast make more shows, then consider supporting us over at patreon.com/automation, where you can unlock insider news and free stuff with your monthly pledge. Now, another way to support us is to grab some of this new swag over at theautomationblog.com/shop. You can see here we got t-shirts, we got coffee cups, phone cases, and more. So check that out over there if you'd like to support us that way. And with that said, I just want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.